Today we're going to talk about quadratic functions. So we'll start out with a definition. Okay, the definition of a polynomial function is let n be a non-negative integer and let a sub n, this is a subscript right here, so a sub n minus 1, a sub 2, a sub 1, a sub 0, be the numbers with a sub n not equal to 0. Okay, so what does this mean? These are just numbers. These are going to be the coefficients. Okay, and this number down here just determines that it's a different one. So a sub 1 is different than a sub 0. And they're saying that the leading coefficient, a sub n, can't be 0. It can be anything else. Then the function given by f of x is a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus this stuff here is called a polynomial function of x with degree n. Okay, so that's kind of scary and everything. It's really kind of hard to read. But if you think about it, all this really is it's something like this. It's a function f of x is, I don't know, 1/2 x to the 4th minus 3x to the 3rd plus 5x squared minus x plus 2. Okay, so here's your a sub n. In this case is the leading coefficient. Okay, here's your a sub 0. That's the constant. A sub 1 would be negative 1. A sub 2 would be 5. A sub 3 would be negative 3. This would be a sub 4 would be 1/2. Okay, so this is a polynomial. And you can be missing any one of these except for the first one. Okay, so this polynomial has degree 4 because that's the biggest power. The degree is always the biggest power. And it doesn't matter what order these are in, the biggest power is the one that's the degree. Okay, definition of a quadratic function. Let a, b, and c be real numbers with a not equal to 0. The function given by ax to the square, f of x equals ax squared plus bx plus c is called a quadratic function. Okay, this is a parabola. All right, and all of these are going to look either like this or they're going to look like this. One of those two. Now they can get narrower, they can get wider, but they're all going to look like this. Your leading coefficient is a, the degree is 2. Okay, the table and equation represent the height h in feet of a projectile fired from a height of 6 feet with an initial velocity of 256 feet per second at any time t in seconds. A quadratic model for the data in the table is h of t equals negative 16t squared plus 256t plus 6 for t between 0 and 16. Okay, so what do we know about this? This has degree 2, that's the biggest power, therefore it's a parabola. We know that the leading coefficient is negative, so the parabola is upside down, so this thing's going to look something like this. We know that this thing starts at time 0 and it ends at time 16. The graph of the quadratic formula. Okay, so this is the formula that you're actually using here. H of t is negative 16t squared plus v times t plus s. Okay, so what does this mean? This number here is a constant for the Earth. So if you throw something or drop something or fire something or launch something on the Earth, your leading coefficient of this parabola right here is always going to be negative 16. V is the initial velocity. So this would be if you were throwing, like you were throwing a baseball. Okay, you're throwing a baseball, you're putting some velocity behind it. That velocity is going to be V. Now, if you were to just drop something, just let it go, that v would be 0 because you're just letting go of it. You're not pushing it forward in any way. So this middle term would disappear. Okay? S stands for start height. So in this case, this was started at 6 feet. So this would be like if I threw a baseball, I would let go of the ball about 6 feet off the ground. So that would be my start height. The graph of the quadratic formula is a U-shaped curve called a parabola. And if you look at this data over here, this is the time in seconds. This is the height off the ground. Okay, so this will actually go a little bit longer than 16 because it hasn't hit the ground yet, but it'll stop when it hits the ground. And the height is 0. But if you look at this, this is very symmetric. Okay, here's the middle. And as you move out 2 seconds, that's the same number. Out another 2 seconds, that's the same number. Out another 2 seconds, the same number. Out another 2 seconds, the same number. Okay. All parabolas are symmetric with respect to a line called the axis of symmetry. This is something you're going to want to know. So if I have a parabola, and let's say it looks like this, the axis of symmetry is a line that goes right down the middle of this thing, just like this. There's your axis of symmetry. It's exactly the same on this side as it is on this side. Now, obviously, my hand-drawn one is not symmetric, but it's close. Okay, so this right here is called the axis of symmetry. And this thing right here, the very bottom of this thing is called the vertex. If this was an upside down parabola, it'd be the very top. The vertex is always on the axis of symmetry. All right. So, library of parent functions. So a parent function for all quadratic functions is the equation f of x equals x squared. So that's your kind of basic function. The basic characteristics of the parent function are the following. The domain. What is the domain? So remember, domain is the numbers that you can put into something. Okay? And if you look at this, they're along the x-axis. I can put any number on the x-axis I want. I can square it. Okay, so I can plug in any number I want. So I write the domain, that stands for domain, equals the set of all x's. Okay, I can put any number in there I want. Another way you could write this if you wanted to is you could write it as all real numbers. But that's what this means. That means all real numbers. Okay, now what is the range? The range, let's put this, we'll coordinate this here. Here's your x's are along here. Okay, that's your domain. Now your range is what comes out of this thing. That's your y's. And if you look at this thing, it stops down here at 0. It doesn't go any lower than 0. So the range is the set of all y's where y is greater than or equal to 0. Okay, that's what that means. The range is the set of all y's where y is greater than or equal to 0. Okay, the intercept. So I have a y-intercept. The y-intercept, of course, is where it crosses the y-axis, and that's right there. So the y-intercept would be the point 0, 0. In this case, it's also the x-intercept. Okay, is this thing decreasing or increasing? Well, if you look at it, it's decreasing along this part right here, and then it increases along here. So here's what we're going to use interval notation. So we say this thing is decreasing on the interval -infinity to 0. Now, this is interval notation. This is not a point. Your clue here, besides context, would be infinity, because you can't have a point that has infinity in it. And it's increasing, excuse me, from 0 to infinity. All right, next. Is this function even or odd? Well, you can always tell if it's even or odd by just looking at the exponent right here. Okay, x squared, even number. This is an even function. Okay, and that means you can't. I guess you can't really say that it's related to it is related to this. Okay, even and odd means this. If it's even, it's symmetric to the y-axis. Okay, so this is a line of symmetry right here, so it's even. This thing is symmetric to that, so it makes it even. If it's symmetric to the origin, which would look something like this, that would make it odd. Now, how does that make it symmetric? Bear with me here a second. If I can take this thing and rotate it 180 degrees and I get exactly the same graph, then that's odd. All right, so this is odd because I can rotate it 180 degrees. This is even because I can reflect it over the x-axis or the y-axis. All right, where is the axis of symmetry? The axis of symmetry is the line x equals 0. All right, that would be the vertical line right there. And does it have a relative min or a relative max? This thing has a relative minimum. At the point 0, 0. Okay, that's right there. That's as low as this thing gets. It doesn't go any further than that. So we'll have several functions that we'll look at where we'll do this and create a library of functions, of parent functions. Okay, now this is what you're really going to need to be able to do. I promise you this is going to be on your test. How to graph a quadratic equation. Given the function y equals ax squared plus bx plus c, find the axis of symmetry. Okay, that's the first step. Now, here's what people always want to do. I even had somebody do this on a calculus test the other day. Okay, they go, let's see, I want to solve this. So x squared plus 3x plus 6 equals 0. And then they'll move this over here. And then they're stuck and they don't know what to do because you can't solve it that way. Okay, so don't do that. I can remember even doing that myself in high school. So find the axis of symmetry. That's the first thing you're going to do. It is always located at negative b over 2a. All right, so if I look over here, the first thing you might want to do is just label a, in this case, is -1, b is 3, and c is 6. So negative b over 2a, in this case, would be negative 3 over 2 times -1, which would be 3/2. All right, so what do I do with that? I go over here, and I'm going to put a line at 1.5. So that's pretty good right there. And we'll turn that thing red so it goes together. So there's my axis of symmetry. Step 2, you're going to find the vertex. So you know the vertex is somewhere on this line. So how do you find it? Well, you take the axis of symmetry and you just plug it in the equation. Okay, so I go Of course, I picked a nice one to do this with, didn't I? So this would be negative 3 over 2 squared plus 3 times 3 over 2 plus 6. Okay, so this is negative 9/4 plus 9/2 plus 6. So if I get a common denominator here, this would be 18/4, and I add that to this, that's going to be 9/4 plus 6. So 9/4 is what? 2 1/4. So this is going to be 8 1/4. So I'd go over here in my graph, and I'd go up to 8.25, would be right about there. So there's my vertex. Now, the next thing you're going to do is you're going to pick 2 points to the right and the left of the axis of symmetry. So when you're graphing a parabola, when you graph a line, you only need 2 points. When you graph a parabola, you need to have 5, and one of them has to be the vertex. Now, that's a little bit of a lie because you really only need 3 because you get 2 for free because this thing's symmetric. Okay, so if you choose the points correctly, you really only need to do 3 points. So here's what I would do is I would make a table. And my first point in the table is always the vertex. So that was 3/2, and that came out to be 8.25. Okay, now what I want to do is I want to pick 2 numbers to the left, and you know, a friendly number generally is 0, unless the axis of symmetry is way over here, then you probably don't want to choose 0, okay, or way over here. You want to pick numbers that are fairly close to the axis of symmetry because this thing will, you know, if it's an upside down parabola, those numbers will get small really fast. If it's right side up parabola, they'll get big really fast. So you want to pick something somewhat close. But I would pick 0 in this because zeros are really friendly. Let's undo that. Okay, there we go. So if I plug 0 in there, I'm going to get 6. I can do that in my head. Okay. Now, I'm going to go ahead and graph the point 0, 6. It's going to go right here. Now, I'm going to use symmetry to get another point. So I went over here 1.5 points, or 1.5. So I can go the other direction, 1.5. That's going to be right there. So I'm also going to get the point 3, 6. Because this thing's symmetric. So I got a point for free. I didn't really have to figure it out. Okay, now another point. I'd probably choose -1 and plug it in. And that would be the same as 4. You can do either one. It doesn't matter, whichever one is easiest for you. So 4 might be easier because it's positive. So this would be -16 plus 12 plus 6 if I plug in 4. So that would give me -4 plus 6 is 2. So these two both come out to be 2. So -1, 2, and 4, 2. There's my 5 points. Now I can draw the parabola just like this. Okay, it doesn't matter which points you choose. I mean, I could have chose 1 and 2. I could have chose completely different ones. I just had to figure them out. If you can get the zeros, which are the numbers where it crosses the x-axis, that's great because you use that for other stuff as well. But you don't have to. Okay, so there's my parabola. It's always the same thing. You find the axis of symmetry by using -b over 2a. You plug that into the equation, and that gives you the vertex right here. Okay, you pick 2 points to the left, and you get the same 2 points to the right, and you graph those, and then you just sketch the curve. This is called standard form. So this is another equation. So remember we had this, f of x was ax squared plus bx plus c. That's an equation for a quadratic function. Well, this is also an equation for a quadratic function. And this is nice because it has the vertex built into it. Okay, so hk is the vertex. So if I know the vertex, I can just write the equation. Now I also need to know another point that's on the graph, because there's a lot of parabolas that have hk. All right, so for example, if I go out here, here's h and here's k, I could have this parabola right here, or I could have this parabola right here, or I could have this parabola right here. Okay, they would all have hk. The only thing that's going to be different about them is whatever this a is, and I'll show you how to figure that out later. You do know that the easy part about this is if it's upside down like the green one here, a is going to be negative. If it's right side up like the blue and the red one, you know it's going to be positive. But you can figure those out. You just need to have a point on the graph. All right, so graph this quadratic equation, 2x squared plus 8x plus 7. Identify the axis of symmetry of the vertex and draw the graph. Excuse me. So first thing we're going to do is we're going to find the axis of symmetry. You don't have to write that down. I'm just doing it for your notes. So that's going to be a negative b over 2a. So in this case, that's going to be negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2. I would go immediately and draw the axis of symmetry on my graph. It's at negative 2, so it's right here. Move that over just a hair. There's my axis of symmetry. Now, next, I'm going to find the vertex. All right, vertex. So I'm going to take the axis of symmetry, plug it into the equation. So I'm going to find f of negative 2. All right, so that's going to be 2 times negative 2 squared plus 8 times negative 2 plus 7. So this is 4, 8, and this is negative 16 plus 7, so that's going to come out to be negative 1. So my vertex is at negative 2, negative 1. So that would go right here. Okay, now in order to draw the graph, I have to pick a couple of points. So I'll make myself a table. And my vertex was at negative 2, negative 1. I'll probably plug in the following points. I would choose negative 1 and negative 3. They're symmetric to negative 2, so that's going to give me the same answer. And 0 and negative 4. So I only have to calculate one of those or two of those. So 2 times negative 1 squared plus 8 times negative 1 plus 7. Right? Yep. Okay, so this is 2 minus 8 plus 7. So that's going to be 1. That's going to be 1. That's going to give me 1. So I'll go ahead and put those on there. Negative 1, 1. Negative 3, 1. All right, 0 is going to be an easy one to plug in there. That's just going to give me 0 plus 0 is plus 7. So that's going to be 7. And that's also going to give me 7. So I'll go back here, 0, 7. It's also my y-intercept, which is always nice to know. And there we go. Now I can draw the graph. Okay, and the graph is going to look like this. And you're done. Identify the x-intercepts of f of x equals negative x squared plus 6x minus 8. Okay, so I need to know where this thing's going to cross the x-axis. All right, so essentially what that means is I need to know when is x squared plus 6x minus 8 going to equal 0. Okay, so there's a couple of ways I could do this. I could graph this thing and see if it comes out. So let's try that. You need practice on graphing anyway. So here's what I'm going to let you do. I'm going to let you pause the video here. I'm going to have you graph this parabola, and then I want you to look and see, does it come out to be nice numbers, okay? A graph will work really great if it happens to cross at like -2, 0, or at 3, 0, or something like that. It works great for that. If it happens to fall in between points like this, then it's a problem. We have to do some other things, okay? But I want you to practice graphing this. So pause the video here, graph this, and then come back and you can check it against what I have. Okay, so if I'm going to graph this thing, remember the vertex, or I'm sorry, the axis of symmetry is at -b over 2a. So that's at -6 over 2 times -1, which is going to be -6 over -2, which is 3. So we'll go put an axis of symmetry at 3. Next, I'm going to find the vertex. All right, and I'm just going to plug 3 into there, so I'm going to find f of 3. That's going to be -3 squared. Now, keep in mind, this is going to be a negative number because there is a big difference between this and that. This is a negative number. That's a positive number. Don't get caught by that. Okay, plus 6 times 3 minus 8. So this comes out to be -9 plus 18 minus 8, which is going to be 1. Okay, so I got a vertex at 3, 1. Right there. This is going to be upside down because it's negative, x squared. I can plug in 0 really easy. I get -8. That's on the graph. I'm also going to get a -8 right there because it's symmetric. Let's pick one number in between, like 1. 1 is easy to use. So if I plug in 1, I get -1 plus 6 minus 8. So that'd be -3. It's going to, whoops, not there. 1 is going to give me -3 right here. I'm also going to have -3 right there because it's symmetric. And so I draw my graph. Okay, now here's what it appears. It appears that my zeros are at 2 and 4. Depending on how I do my graph, though, it might be hard to tell. So how can I get it exactly? Well, I can take my equation, plus 6x minus 8, set it equal to 0, and I can solve it. Now, how do I solve it? You can factor it, or you can use the quadratic formula. Okay, on this one, I would recommend using the quadratic formula. So, remember the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. You need to know that. Okay, so x would be, -b would be -6 plus or minus the square root 6 squared would be 36 minus 4 times a would be negative 1 times c would be negative 8 all over 2 times negative 1. Now if I look in here, those two negatives cancel. I get x equals negative 6 plus or minus the square root of 36 minus 32. 8 times 4 is 32. So that's going to be square root of 4 all over negative 2. Square root of 4 is 2, so this is negative 6 plus or minus 2 over negative 2. All right, so x would be negative 4 plus 2 would be negative 4 divided by negative 2, which is going to be 2. Hey, that confirms what we got right there, doesn't it? And then negative 6 minus 2 would be negative 8 divided by negative 2, which would be positive 4, which, hey, look at that, it corresponds with my 4 over there. So if I did my graph precisely, I could get it, but this definitely gave me the zeros right there. So the original thing was find the x-intercepts. So the x-intercepts would be 2, 0, and 4, 0. That's your actual answer right there. I would not recommend graphing to find x-intercepts, unless it tells you in the directions to do that, in which case you don't really have a choice. I would either factor. I choose to factor most of the time because it's much faster than using the quadratic formula. But if you're not great at factoring, which you need to get to be, you can use the quadratic formula and it always works. Sometimes factoring doesn't work. So if you've got some weird answer, if you have an irrational number, you might not be able to factor it. Okay, writing the equation. So you'll have to be able to do this as well. The standard form of the equation of a parabola whose vertex is 1, 2, and that passes through the point 3, negative 6. Okay, so here's the thing. I know that this is the vertex, and I know this point is on the graph. So if you go back and you write down your, if you go back and look at your standard formula, a times x minus h squared plus k. Okay, so my vertex is at 1, 2. So this is going to be, I'm going to go ahead and kind of color coordinate this here for you. That's going to go in like that. All right, now that doesn't really help me a ton because I've got too many variables here. I don't know what A is. So A is going to determine how wide this parabola is. So how do I figure out what A is? Well, that's where this point right here comes in handy. So I know that somewhere on this, when x is 3, y is 2. So I can go ahead and plug those in. There's y. And x is, whoops, it's not y. Y is negative 6. X is 3. Okay. There you got everything. Now I've only got one variable. I can figure out what A is. Okay, so I know that this 3 minus 1 is 2, squared is 4. So this is 4A plus 2 is negative 6. So I can subtract 2 from both sides, and I can divide by 4, and I get A is negative 2. So now I can write my equation. So my equation is going to be y equals negative 2 times x minus 1 squared plus 2. And I'm done. That's standard form. Now, if I need it in the other form, I can, square this and combine and multiply by -2 and combine my like terms and all that kind of stuff. But that's good enough for this answer right here. And that's going to give me a parabola that's going to look like that. Okay, so what did I do on this? I substituted in the vertex where it goes in the equation. I substituted in the point that I knew was on the graph for the x and the y. I solved for a, and then I just put it back in here, and then I get this. Now, if you need it in the other form, I might as well just show you how to do that. Okay, so I would take this and square it. So remember, you're going to FOIL. Okay, so this is x minus 1 times x minus 1. And so you're going to get -2 times, so the first would be x squared. The outside would be -x. The inside would be -x. The last would be +1, +2. And then I'm going to combine my like terms here. I'm going to distribute my -2. I'm going to combine my like terms here. And that would be the other form. So this equation and this equation are exactly the same equation. If you graph them both on your graphing calculator, you're going to get the same graph. Okay, finding minimum and maximum values. The minimum or maximum of a quadratic equation will always be found on the axis of symmetry. Therefore, if you want to find the minimum or the maximum of the quadratic, simply find the axis of symmetry, plug it into the equation to find the vertex. The minimum or maximum will be the y-coordinate of the vertex. So find the maximum or minimum of this equation. F of x is -0.0032x squared plus x plus 3. Okay, so the axis of symmetry is going to be at -b over 2a, which is going to be -1 over 2 times -0.0032, which is -1 over -0.0064. Wow, that's ugly. So I would take this right here. Let's see, the negatives cancel. All right, I'm going to take this right here, and I'm going to plug it into here and here. So I'm going to get out my handy-dandy TI-84 plus C Silver Edition graphing calculator. And I'm going to go ahead and plug that in. So -0.0032 times, in parentheses, 1 divided by 0.0064, close the parentheses, squared, plus, in parentheses, 1 divided by 0.0064, close the parentheses, plus 3. Boom, 81 point. Comes out to be 81.125. Okay, now this is negative, so it's upside down. So I know that this thing is a maximum. Because it's an upside down parabola, it's going to look like this. It's going to have a maximum right there. If this was positive, I would know that would be the minimum. Okay. Ooh, check this out, a bridge that is made from a parabola. How exciting. Okay, so here's your assignment. Since you don't have books, I took the liberty of adding, and it's a little out of focus. I can't help that, that's the software, but it's all readable. Here's your problems right here, okay, on the next 3 pages. Okay, and if you have trouble reading it, let me know. But that's the best resolution I could do. This equation right here is the one that's the most difficult to read, and I'll go ahead and write that. It's y equals negative 16 over 2025 x squared plus 9/5 x plus 3/2. Okay? And then that goes with all this problem right here. So, there you go. Do that assignment that is due next class. And you don't have to copy down the problems or anything. Just do the work. I mean, if you've got something simple to copy down, you might do that. But make sure that you do your work. Take a picture of it, show all your work, and email it to me, and I'll get it in the grade book. Okay, talk to you later.